Hello, in this video, we're going to review measures of variation, which goes along with section 3.2 in your textbook. You can access guided notes to follow along with the video on Blackboard. Objectives. Students will be able to develop the ability to measure variation in a set of sample data by finding values of the range, variance, and standard deviation. Also, students will be able to interpret values of the standard deviation by applying the range rule of thumb to determine whether a particular value is significantly low or significantly high. In this section, we're going to go over three measures of variation: range, standard deviation, and variance. We'll find that some of these are biased estimators and others are unbiased estimators. For example, the sample standard deviation S is considered a biased estimator of the population standard deviation, which means that the value of the sample standard deviation do not tend to center around the value of the population standard deviation. We say that the sample standard deviation does not target the population standard deviation. On the other hand, the sample variance, which is S squared, is considered an unbiased estimator of the population variance, sigma squared, which means that the value of S squared tends to center around the value of sigma squared instead of systematically tending to overestimate or underestimate sigma squared. So we say that the sample variance targets the population variance. Now, the other measure of variance that we talk about in this section is range, and range will be considered a biased estimator. Now, in this section, you just need to know whether it is biased or unbiased. Later on in the course, in Chapter 6, we're going to talk about sampling distributions, and we'll go into detail to see exactly why we would consider it biased or unbiased. But for now, you just need to know the vocabulary and the association. Rounding rules. As we get into this section, when you're rounding a value of measure of variation, just like we did for the measures of center, carry out one more decimal place than you see present in the original data set. Now let's look at our first measure of variation, the range. The range is the difference between the maximum and minimum data value. The range is not considered to be resistant, which makes sense because it only takes into account your extremes, your maximum and your minimum. It doesn't take every value into account, so it doesn't truly reflect the variation among all those data values. So for range, we say the max minus the min, and sometimes we'll use a capital M minus a small m to denote that. So as an example, we have some data from Verizon data speeds in megabits per second. We have 38.5, 55.6, 22.4, and 14.1 and 23.1. We'll use this sample data throughout this lesson. The highest data value, or the maximum, is 55.6, and the minimum is 14.1. So the range R will be 55.6 minus 14.1. The range of this data is 41.5 megabits per second, and it's important to put the units on your answer. The next measure of variation is the standard deviation, a measure of how much data values deviate from the mean. I like to say that the standard deviation tells you on average how far a data value is away from the mean. So it's usually positive, it's negative, never negative. That means it can be a number that's 0 or greater. So if it's not negative, it can be 0 or greater. So that means the standard deviation is always greater than or equal to 0. It's only 0 if all the data values are the same number. And that makes sense because if it's telling us on average how far data values deviate or go away from the mean, if they're all the same, then on average they're not going away from the mean at all because the mean will be equal to the data value all the time. They're not resistant to outliers. The units for the standard deviation will be the same as the units of the original data value. So if your original data is in centimeters, the standard deviation will be in centimeters. Larger values will indicate larger variation. And yes, it's considered a biased estimator. You'll see here that we have formulas for the standard deviation. There is a sample standard deviation formula and then a shortcut version of it. And then there's a population standard deviation formula. Now, you might have to determine which one you will use. If you have a sample, you're going to use the one with the S. If you have a population, you're going to use the one with sigma. Notice the difference between the formulas. In samples, we have our standard English alphabet with X and we have a bar over it. Instead, in the population, we have mu there. In the sample standard deviation, we have n minus 1. This is to account for error in our sample, whereas in the population formula, we have capital N to include all the data values. I expect you to be able to recognize which formula you should use, the sample formula or the sigma population formula. I strongly recommend that you use your graphing calculator to calculate these wherever possible. And remember, you have that calculator steps document. Let's go ahead and find the standard deviation for the data for the Verizon speed times. In your calculator, you're going to go and press Stat, Edit, and type in these data values into list 1. Mine are already there. Pause the video and get yours in there so you can follow along with me. Once you have your data values in, what you're going to do is press Stat and press the right arrow to calc, and then press enter on one var stat, or you can just press the number 1. Our data was in list 1, so make sure you press second and the number 1 to get list 1 if it's not already there for you. We didn't use frequencies, so I'm going to delete my frequencies here. And then go ahead and press enter on calculate. And you'll see I have a whole list here. This is how we found the mean for data in our last section. So I can see X bar, the mean here, but then if I go down, I see S and I see sigma. S is our sample standard deviation and sigma of X is our population standard deviation. So what you need to know each time is whether you're working with a sample or a population. In this case, we don't have all of the Verizon data speed times, so this is a sample. So we're going to use S, and our answer will be 16.45 because our original data went out 1 decimal place, and our sample standard deviation should go out 1 more decimal place than the original data. So let's write that down. Our final answer would be 16.45 megabits per second. Now that we know how to calculate standard deviation, variance is simple to calculate. It's simply the square of the variation. For a set of values, a measure of variation is equal to the square of the standard deviation. For sample variance, we have S squared. For population variance, we have sigma squared. And I keep saying this here, but it's SIGMA. And you kind of make a U and then curve it over to close up that U to make the sigma symbol. So here we have the notation for you. S sample standard deviation, S squared sample variance. Sigma population standard deviation, sigma squared population variance. So using the data from our last example, let's go ahead and find the variance. S was equal to 16.45. That's our standard deviation. So S squared is going to be 16.45 squared. We get 270.60 megabits per second squared. Notice the units are squared, and I'm still rounding 1 more decimal place out than my original data. Using information that we know, we can find the coefficient of variation, also denoted CV. So for any set of non-negative sample or population data, it's expressed as a percent rounded to 1 decimal place, and it describes the standard deviation relative to the mean. And literally all we do is we take the standard deviation and we divide it by the mean of the data, and that gives us a decimal. We'll multiply that by 100 to turn it into a percent. And you do the same thing whether you're working with a sample or a population. We just have different notation for sample and population. So we can find the coefficient of variation for our data speeds that we've been working with for this whole video here. So we already know that we have our standard deviation is 16.45. And I can check my calculator screen to see what x bar, the mean, was. You can see here when we did our 1 bar stat, the mean was 30.74. Now we can fill in the formula. Our coefficient of variation is 16.45 divided by 30.74, and then we'll multiply by 100. Our answer to 1 decimal place is 53.5%. So the standard deviation relative to the mean, our description of that is the coefficient of variation, and in this case it's 53.5%. Tune in to the next video to learn about the empirical rule and also the range rule of thumb.